Okay, so it looks like we've had a great kind of lively discussion back and forth with the authors on Slack throughout the talk. Maybe I can take the most recent unanswered question in Slack and see if one of the authors wants to try and answer it live. So Dave in Slack asks, the queries, the scripts that you've got using D3RE are sort of smaller in terms of lines of code, but one question is whether they're actually faster to develop because debugging these kinds of declarative programs could maybe be harder than debugging something like a Python program.
Yeah, so I think like how to debug the rule here is like you just write your rule and run and to see like you can like mark it in the like GUI interface, and then like because like in our current implementation, like rerun a rule is very cheap because you won't rerun every rule. You just rerun the script just relate to your current part. Like we forward like the previous results of your previous query like into our internal database. So like if you just rerun a small part of the program, I think that's not too hard.
Right, see, we have other questions in the audience. Let me just make sure no one's got their hand up. Okay, so maybe I can ask a couple of questions of my own. So one question that I had was sort of just about scalability. I know you mentioned sending these off to supercomputers to solve, but assuming that I want to sort of stick with analyses just like on my local laptop, I assume there are probably some practical limitations to the sizes of binaries that I could tackle. And so, do you have a kind of rough sense in terms of binary size of what the limitations of D3RE right now?
Yeah, so right now, like I've tried a lot of different sizes of binary. So I think for like maybe like size under 10 MBs will be fine. But if like it's extend to like above 10 MB, that could be pretty hard because like you need more than like 16 gigabytes RAM for like decode this thing and like to generate databases.
Yeah, so that's so that's the limitation of DDSSM. So I mean, I would honestly say not to discount it, it's also a limitation of D3RE, but I would say that the reason we're limited in that way is because, yeah, it's pretty complicated to run these things on, you need a lot of RAM, actually, it turns out. And that was one of the motivating factors for us in fact, that was sort of one of the most motivating reasons that we wanted to run it on this MPI-based backend, is that we want to run it on things like Firefox and stuff like that. Well, Firefox is kind of a bad example because the binary just loads up a bunch of dynamic libraries, but large binaries. And I would say practically, I don't think it's a huge limitation in the sense that it really depends on the analysis you do. So if you're just disassembling, DDSSM is pretty much linear in size of the code. So if you want to assemble, we're able to do pretty big binaries. I think like Yihao said, 10 megabytes with 16 gigs of RAM. But I think it's the kind of thing where if you want to do slightly larger binaries, you just go rent the next largest machine on AWS, and then that's got 96 gigs of RAM, or you can get a machine with like 300 gigs of RAM. And the main limiting factor is just going to be the complexity of your analysis. So if you write an analysis that ends up producing an exponential number of paths or an exponential number of facts for the binary, well, then you're going to be sort of exponentially limited in some way. So I think that probably in practical terms, there's sort of order of magnitude considerations where most of the kinds of analyses you want to do are pretty linear. But yeah, in fact, some of them get quite large. We were disassembling, things like Souffle, and they blew up on our laptops, kind of surprisingly. I think we kind of thought that DDSSM would be able to crush everything. However, the ones that it could fit in memory, it did them very fast and very accurately. So that was awesome.
Cool, thank you. I guess I have one kind of follow-up question, which is sort of about the, kind of expressiveness of queries supported. One thing that's been traditionally kind of difficult if you want to do an analysis in something like maybe anger is supporting things like interprocedural kinds of queries where you want to, make statements about data flow across different functions. And is that something that is easy or difficult in a data log kind of framework?
Yes, I think it's also like hard like for interprocedural analysis for now. But so our plan is like we will like in later step like we will build like more like base like rules like integrating more base rules into our facts. For example, like we can like make more rules to support this kind of thing, like as a initial database for our tool.
Yeah, I mean, I think doing sound, precise interprocedural analysis of binaries, it's so hard because if you don't have assumptions. So one of the core things that we're excited about with D3RE is that you're going to be able to explicate assumptions about the binary. You're going to be able to say, assume this is always called as a function with this calling convention. once you can do that, you can then start to build up sound binary analyses that essentially treat segments of the binary and soundly abstract, well, soundly with caveats, but those caveats have been explicitly enumerated. So you can actually understand them as like a structural thing rather than just like, well, your analysis is kind of unsound. You can get your hands on them as a structural thing and be able to say, all right, well, now that I can assume that the analysis worked its way to get to this function, okay, well, if I assume that that function can be called, but doesn't make a side effects on this part of the heap, for example, then I can be able to get past that. Now, how you embed what actual logic you use, how you embed this, how you come up with the right combination of program logic, program analysis, that's a real engineering challenge. We haven't solved that yet. That I think I think it's a really challenging and interesting problem that we hope will become Yihao's work down the line, basically.
Yeah, and I think another thing that good using like data log things is that like we can control the search space easily. Like you can specify like what is the address, like from which address to what address like you want to search and apply analysis on. Like because for some like traditional tool, like you can't just easily say that I want to do analysis in this and this, but not like most of tools like do the whole program side. So I think that's one thing is good for our tool.
Thank you. All right, maybe I've got maybe just one quick last question before we move on to the next talk, which is basically how easy it is to kind of feed the results that you get from D3RE back into Ghidra. So, maybe I might want to design something like some kind of type inference in D3RE. Is it easy to then kind of feed that back so that, say, Ghidra's decompiler can take advantage of it?
No, I think for currents, no, I would say. So for now, it's like first, our tool looks like first the DDSM and then do analysis. So if you want to back to like DDSM procedure, like for now it's not possible, but I think that's doable maybe in the future. Yeah, because like we are using like data log style thing. Like we can add a patch to DDSM maybe and let it rerun to generate new DDSM result.
Okay, great. Well, thanks for the fantastic answers and a great talk. I'm really happy that the Slack discussion was also very lively throughout the talk. I think this is great, and makes it really makes me appreciate this kind of nice workshop format. So thanks to the authors.